Assalamualaikum student. Today we discuss the topic that is related to terminal velocity. Here we take the example of the sky diver. First we take when the sky diver just jump out of the aircraft, then what is the terminal velocity? When the sky diver is just jump out of the aircraft, then air resistance is small. Air resistance small, so speed increase. So only weight of the object that is acting downward and air resistance is small, so speed is increase. When the skydiver is moved further, speed increase. So a time come when the air resistance is balanced, the weight of the person and attain terminal velocity. At this point, air resistance is balanced by the weight of the body. When open the parachute, then air resistance increase and weight become smaller. So here we write this is the parachute open. When the parachute is open, large air resistance cause the person to accelerate. Time become at they again attain the terminal velocity. Air resistance is balanced by the weight of the body. That is all about the sky diver example, how it attained the terminal velocity. Now we discuss the graph between speed and time, how speed increase and how it attained terminal velocity when a parachute jump from the aircraft. First we discuss the graph between A and P. When a parachuter jump from the aircraft, air resistance small, so the person accelerate. When the person accelerate, then the air resistance is also increase with the time, so person speed increase, so air resistance increase. Between C and D, air resistance balance the air resistance balance the weight of the person attain constant terminal velocity. Between D and E, parachute open, person open the parachute open, air resistance large. When the air resistance large, cause the person to accelerate. The graph between E and F again attain terminal velocity. So in the parachute jump, the parachuter attain 2 times the terminal velocity.